Here's the solution to question 1 of homework 3. From this title, we can find 4 problems. Let's begin the first one. Finding A so that the probability x equal k it represents a probability mass function. Here's the solution. The probability of x equals k represents a probability mass function, so we can get the sum of the probability equals 1, and the probability expression is this. And let's assuming the sum of the probability equals xn. In order to figure out the value of a, we have to do something about these equations. Uh, so we can get what we must name this equation. Name equation 1, and equation 1 times 1/3 we can get the equation 2, and equation 1 minus equation 2 we can get this equation, and from this equation we can find this one is the geometric series, so we can use the sum of the is geometric series. We can get this one, so we can get this equation, and because k intends to infinity, this expression equals 0, and this one equals 0, so we can get the a equals 4/9. And let's begin the second question. Is finding the mean of the x. The mean of x equals this expression meaning that the sum of x times the probability of x. We can know that a equals 4/9, so we can get this equation and name the equation 1, and then we can know that we can in order to figure out Sn, the value of Xn, so we have to do something about this equation. Firstly, we can do that equation 1 times 1/3, we can get the equation 2, and 1 minus 2, we can get equation 3, and in equation 3 we can find out that this equation looks like the geometric series, but it doesn't, so we have to continue to do something to about the equation 4 equation 3, I'm sorry, equation 3, and we can then equation 3 times 1/3 we can get equation 4, and equation 3 minus equation 4 we can get this this long equation, and and then we can we can find out that this is the geometric series, so we can use the formula of the sum of the geometric series, and so we can get this. We can simplify that look like this, and then because k intends to infinity, so we can get this one equals 0 and this one equals 0, so we can get Sn equals 2, meaning that the mean of x equals 2. Let's begin the third question. is finding the mean of x square, and we can um, we can know that the mean of s square equals x square times the probability of x, and 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 add them all and look like this. This is the equation 1, and we can we can put the equation 1 times one third, we can get equation 2, and 1 minus 2, we can get equation 3. um, and then equation 3 times one third, we can get this equation, and equation 4, and equation 3 minus equation 4, we can get equation 5. But just look like this. This one is look like the geometric series, but it doesn't. So we have to continue. And equation 5 times one third, we can get the equation 6. And equation 5 minus equation 6, we can get this one, this long one. And we can know that uh, this is the sum of the of the geometric series. So because k intends to infinity, so this one is 0, and and this long one equals 0. So we can simplify that the equation, this equation, just like that, and we can figure out Sn equals 5.5, and the meaning that the mean of the x square equals 5.5. Let's finally let's begin the final problem. Uh, we we must from the final problem is finding the conditional probability mass function, the probability of x equal k, assuming x is not larger than 1, less than 10. Let's begin this question. We know that the probability x equals k, assuming x is larger than 1, smaller than 10, equals this expression. And if k is greater than 0, this probability equals 0. So the conditional probability equals 0. And if k is greater than 1, smaller than 10, we can know that this the probability x equals kx is greater than 1, smaller or equal 10, uh, equals the probability x equals k, and equals this is expression. And assuming Sn equals the probability x is greater or equal 1, and smaller or equals 10, we can know that the sum of this probability, and renaming the equation 1, and equation 1 times one third, we can get equation 2, and equation 1 minus equation 2, we can get this equation. And this one is the geometric series, so we can use the formulas of the sum of the geometric series, we can get this one. And we can figure out Sn is equals 1 minus this one, and this one is intended to 0. So we can use the is intending, and we can get this Sn is intending to 1. So we can know, finally we can know the conditional probability equals this expression. This is the solution to the question 1. That's all. Thank you.